Starting now.
Okay, so now today we will have an important topic. Okay, so that is your schema. Okay, so let's discuss on the schema part. Okay, so there will be a logic for the schema design. Okay, why you need so let's say you have a tables here. Okay, you have departments, then you have employees, and you have salaries here. Okay, so you will have a key decision of choices. Okay, so department id, okay, which will be our primary key in the entire tables. It will be our primary key. It should be unique on the department name. Okay, it should not be a duplicate. Okay, so why you require this department name is primary key. Okay, it will prevent your duplicate names with the other departments. Okay, it will be auto incrementing your uh, primary key. Okay, it will simplifies your joins. Okay, so now you will have joins, then you have employees. Okay, so you will be having a unique email, and you will have a delete set also. It will be not a null, and it will be a foreign key. Okay, then you have salaries. Okay, so let's see with the examples we will see how these are correlated. Okay, so you have inserted some data in the departments, like your department, engineering, human resource, sales, all you have done with the departments you have inserted. Okay, then you have inserted employees also. Okay, then you have inserted salaries also. Okay, so now you are verifying the data. Okay, so you are verifying the data. Now you see it here in the graphical presentation how it will be. Okay, so I will increase little bit. Okay, why it is going this much? Okay, I will make this as 2030. Okay, so this will be fine, right? So you inserted here in departments, then employees and salaries. Okay, so this is your all tables. So this is your primary key for this table, and primary key for employee id, this is your employee id, whereas your department id here will be your foreign key here. Okay, you are linking this table from this one to this. Okay, then you are linking it, you are linking salaries to your employee id here. Okay, so your employee id is coming up in here. Okay, so salaries, salary id, then employee id. Okay, so these are all your design. Okay, then you are verifying it. Okay, so final result. Okay, if you are doing it final result, now you are joining the all records you are joining. So first name, last name, department name, and base salary and effective date. Okay, so with this information all the duplicate information is removed. Okay, that is how why you will need a schema. Okay, so if you look at it, the logical blueprint. Okay, so this is how it will be domain driven. Okay, like your data model, like specific rules or compliance, you will be doing it for a business need. So we will see with another example also. So let's have a, so our database is having a large, like hotel, house and hospital. So I am using all the three use cases here. Okay, my database instance. So I am using a asset management. Okay, so I have hotel hospitality management. Okay, then this will focus on short term stays, and it is dynamic pricing and daily returns. So this is my requirement. Okay, and my compliance is here I am using a credit cards here. So my hotel is using a credit card system where I need to be compiled with the DSS standards, and I am collecting the information also. So in India we have now from July there is a DP Act, okay, Data Protection Act, okay. You cannot hold the data if it is not required. If you are holding that data, then government will give will put a fine 2050 crore. They will put that fine. This is what the new law says. From July this is applicable, okay, DP Act, okay. So I am collecting the private identifiable information also, PII, okay. So my objects here are tables, okay, rooms, booking, folios, and then view, okay, occupancy rate, what are all the rooms that are occupied. This is my schema, okay, for hotel, okay. Now I have a schema for real estate. So it is a long term ownership, okay. This is short term, this is long term, okay. I have leases and then property appreciation. So compilance is, these are my compilance, and my tables are properties, deeds and leases, okay. So it is a portfolio yield, okay. Here it is, my view is occupancy, okay. Here it is a portfolio yields, okay. Now I have a health care here, okay. So I have a patient care, clinical outcomes, okay. Long term health records. I am going to manage the long term health records. So I am compiled with the HIPAA standard, and it is a high tech. So my tables are patients, okay, encounters and prescriptions, okay. So encounters is nothing but how many times they have visited it, okay. And I am using the views or my bed capacity, okay. So this will be my business, core business based on that. So now you are separating all these into distinct schemas, okay. So you need to apply a security policies for a hospital billing clerk, get only access to the healthcare hospital schema, okay. He should not see that hotel booking data. See, my company is having these three area of business. Healthcare should see only the healthcare hospital data. They should not view my hotel booking data, okay. So now you see it here, hotel hospitality, it is focused on this, and this is all it is focused, okay. Now it is tables, all this is in a graphical context, okay. I don't want to explain. This is how that focus is, my database. So I have tables here, I have views, and these are my objects, okay. How I am managing it now, okay. So my logical schema, okay, for each domain I am putting it how the relationship will work, okay. So I have a unique user identifier here, okay. I will put guest name, guest ID, full name, loyalty tier, and then date of birth. These are my primary key, okay. This is for hotel schema, okay. This is for hospitality, okay. So here I am giving a maximizing, so my focus is maximizing occupancy, and then managing short term slots, time slots, and dynamic billing. So this is my core business for hospitality. So my schema, I am designing it, okay. My booking tables, okay, this table, booking table relies heavily on the time bound constraints, check-in and check-out, okay. So this is where my profit will come, check-in and check-out, okay. The schema must enforce a rule that a single room ID cannot be given or overlapping for the different booking ID. See, if somebody is booking this room ID they should not be overlapping with the different booking ID. No double booking should not be present for a single room. Okay, that is my core business. So if this is done, then I will lose the business. Okay. Okay. So now for the room here, okay, it should be boolean here whether it is available or not. Okay, this is for view. Okay, this is what makes my schema. I am defining it for hotel. Okay, so now I am doing it for house schema now. Okay, so this is for real estate. Okay, so now I have a owner here. My business focus is on long-term asset management and legal ownership, maintenance and lease agreements. So this is where my business lies. Okay, so unlike that hotel schema which track days, okay, the real estate tracks here higher period, okay, months and years. Okay, so this property table holds a static value. Okay, long term you will have a asset data here, what is the market value and what is the year built. So this is market value and year built. Okay, this will be enforcing your referential integrity. Okay, to ensure that there is a lease agreement cannot exist for a property that the system does not recognize. Okay, so here if that property does not, if it is not existing here, it should not recognize this lease agreement. Okay, so schema enforces referential integrity to ensure a lease agreement cannot exist for a property that the system does not exist. So this is the main area. Okay, if it is having, then only you need to have a lease agreement, or else you should not have any lease agreement. Okay, so this you are enforcing it, this schema here. So if you are not enforcing, then you are gone. Okay, so a lot of fake agreements will be made here. Okay, so you are designing it based on your core values. Okay, this cannot be compromised like that. Okay, so let's say contact info. If contact info is blank also, you will accept it. Okay, so here you need to have a complete information. So this will be your primary key here. Okay, then you go with the hospital schema now. Okay, healthcare. So your focus is on the clinical accuracy, patient safety, strict audit trials, okay, and regulatory compliance. You are not going to compromise on any of this for business parameters. Okay, so the most critical aspect of this schema is auditability and privacy. Okay, so if somebody comes in and audits it, you should be able to show all that linking between this, or else your license will get cancelled. Okay. Okay. Now clinical underscore encounter table contains highly sensitive data. Okay. So here this is having a highly sensitive data. Okay, this you need to protect. So patient ID, foreign key. So this is your encounter ID. Okay, then your doctor ID. These are all the primary key, and these are the foreign key. So you have patient key, patient here. This is the table. This is your unique identifier for a patient. Okay, this will be primary key here for the table. So medical records, and these are the strings for that particular medical record. So then you have doctor here. So doctor ID, it should be primary key here. and you have all that specialization and everything here. Okay. So patient undergoes and doctor conducts it. Okay. So this is the key area, okay, which you will be focusing now. Okay. The schema here must integrate with the database auditing tool to track who viewed or modified this record. So let's say patient came for one first visit or second visit. Okay. So some doctor has modified the prescription. Okay. Let's say you want to trace back who modified that particular prescription, when it got modified, who viewed it, all that information, it should be there. This is my business. Okay. If you are not giving this information, you will your license will get cancelled here. Okay. So this information will be fetched from these two tables. Okay. So this is how you will be designing your schema here. Okay. So
there is a encounter ID for foreign team, sorry, primary team.
Yeah. So this is your visit ID. Okay. Patient has visited this second time. Okay. Third time he visited. Okay. The prescription has changed here. Okay. Treatment has got changed. Okay. Who has changed this prescription? So you will see. Okay. The doctor ID. Okay. This doctor has changed it. Okay. So all that it will be traced back here. Everything you need to trace back or track it, who modified and why them, when it got modified. Okay. So now you are having a key takeaways as a database admin. Okay. So you have to design that, okay, across all the domains. Okay. So here in hotel schema, nightly rates are a dynamic variable. Okay. That might change daily. Okay. Data types, that dictates business logic here. So these are going to change dynamically. Okay. They are a dynamic variable.
I didn't understand. Give me example. Nightly rate is a dynamic variable that might change daily.
Okay.
I don't understand.
Okay. See, let's say you have a what is that? Christmas Eve. Okay. So all the bookings from December 10 to January 10, so your booking rates will get changed automatically. So these are dynamic. Okay. So your nightly rate, okay, these are dynamic. It will keep on changing every day. Based on the demand, this will keep on changing. You should not put it as a static. Okay. This will keep on changing. And the guest ID and full name, okay, if you are giving it, this should not change. Okay. If you are giving unique ID, it should match. Okay. This is static and this is dynamic. Okay. So and this will be Boolean. Is it true or false? You should not put any value here. Okay. Is it available? Yes or no? That's it. Okay. So here room type also like that. Okay. Is it luxury, normal, all that types. Okay. 3-4 types. That's it. But here this will be your completely changing. Okay. This is where your business lies. Okay. So this is where you will view the business, check in and check out. This is your business flow. This is where your profit will come. Okay. So this is all your logic. So this is where your logic lies here. So data types dictates the business logic here. So in house schema, your monthly rent is fixed variable, locked in for a year. So you are not going to change it. Okay. So then your hospital schema is, so you are strictly adhere to a medical coding system. Okay. So it should enforce the check. Okay. You cannot directly commit it. You should have a check. Okay. Constraints. So we will see that what this check constraints is. Okay. So now you are seeing the complete life cycle management. Okay. So in hotel management, in hotel booking, it is highly transactional. Okay, and it is created, fulfilled and archived quickly. Means, so every day it keep on changing. It is very fast, and you will have lot of transactions. Okay, this is the life cycle management of the hotel booking. Whereas here in house and lease agreement, this is long lived object. Okay, so which will have a historical records. You won't get that transaction every day. Okay, it will be like historical. So you will be tracking it renewal. So yearly you will be tracking it. So here you are tracking it daily. This will be, you will be tracking it monthly or quarterly or annual. Okay. So then you have a clinical encounter. Okay. This is completely permanent. Okay. And it can never be deleted. You should not be deleting any of the record no matter what you do. Even if you do mistake also, you will only append it. Okay. So the schema must design to prevent hard deletes. Okay. So you will be applying only appends only on this table. You will remove that option called delete. Okay. So because these are the constraints that you will be keeping in mind, so that you are adhere to the compliance. Okay. Then you have a cross domain integration now. Okay. So now your organization is owning all these three business. Let's say Reliance is owning this business, or any company is owning this business. Okay. So you wouldn't just let the schema exist in isolation. Okay. So you need to have a enterprise data model to map everything. Okay. I am a customer of the particular company, where I will be using their hospitals, their resorts, and then what is the other one? Okay. And their guest also, their properties also. So I will be using all these three programs. Okay. So let's say you have an example here. Okay. How does a patient in hospital schema map to a employee? Okay. If they are a doctor in the HR schema. So in the HR department, an employee is a doctor. How he will be treated as a patient? So that is one question. Okay. So let's say, how does a owner of a property map to the guest in the hotel if they are the same person? See, I am a property owner. Okay. I wanted to book it as a guest. I want to do a booking for that particular hotel. So if I am booking it, how you are going to handle it? So those are things. Okay. You will be looking at how you are doing it. Okay. I will pass. So now you see that importance of the schema design. Okay. What is the core concept of designing schema is, your data should be accurate. Okay. And it should be consistent across all the data source, wherever you pull that information, it should give the same result. Okay, and the data should grow. It should not stop, or it should not tell, okay, I have done it, my capacity, I cannot take anything now. So that's it for me. I cannot put now in the table. So please create one more table. It should not do like that. So it should scale that volume even if there is a full user demand. Okay. So then that is scalability. And so whenever you perform a query, that should give you the result very fast. So you are querying it, the customer wants to book the hotel. So you are telling, okay, you just 2 minutes, it is taking 2-3 hours. Okay, that should not happen. So that should happen very quick. So booking all, you are taking appointment, or if you are doing any property agreement, everything should perform in fraction of seconds. Okay, so you need to have that improvement also. Okay, so that also you need to take care. Then you need to have a maintainability. Okay, so if you want to update anything, or if you want to debug something, or if you want to upgrade something, you should not have a complex things. Okay, it should be easily upgradable. Okay, so those things. Okay, now you see that the importance
Sir,
here.
I'm not able to see its screen.
Start it. Okay, so here in data integrity, okay, it should be accurate and it should be reliable across all the data source. Okay, it should be not like preventing negative salaries, duplicate emails. All by design you have to ensure that there is a data integrity. Okay, your data is not tampered across all the tables. Okay, so then you need to reduce the query latency here. So whenever someone queries it, you need to have a proper primary key and foreign key, and it should be indexing also. So indexing is like just how you have installed that everything in your laptop. Okay, so it should be very quick. If you type something, it should come immediately. So like that you need to do that performance optimization. Okay, so then it should be having a scalability. Your data volume should grow seamlessly. Okay, so you are auto incrementing all your primary key and your normal structure also. Okay, so then you need to maintain the simplify the updates. Okay, and making it easier to manage constraints on delete, set, null. So all this you will be doing it by looking at this. Okay, then you have why you are making this design, why schema design is required. So it will prevent your data redundancy. So you are not collecting all the data again and again. Okay, so you will just pull that information based on your foreign key and primary key. Okay, you will put it and you will enforce the relationships. So with that you will pull the data here. Okay, which will give you consistency. So you are not if you are adding the data again and again, there will be a problem with consistency. And whatever you design it, it should support your business logic. Okay, this is why you required a schema here. Okay, so these are the reasons why you are designing a schema. Okay, with
But the main key point is the schema always support, and it should support business logic,
yes,
right?
yeah. So not only business logic, it is the core business logic, but it has to enforce all these things also. Okay, so this is where business will run. Okay, but you should also have this as a key factors also. Let's say this is your 50%. Okay, so all these rest of these things you need to make sure that this is your 14%, this is your 15%, then this is your 20%, like that. Okay, so it is not like 90% you are making this and you are giving this 3%, 3 and 3. Okay, it is not like that. Okay, you should give 50% to the business logic. Okay, and then your 50% is this one. Okay, and it should be 100% accurate, then only it will run. Okay, your schema will run. Okay, now you have indexing. Okay, what is your indexing? Okay, it will auto create a clustered index. So whenever you are querying something, okay, if you are heavily querying, then you will create a index here, so which will give you immediate result. Okay, so now you are handling currency also. Consider a currency lookup table. Okay, so if you are dealing with multiple currencies also. Okay, and then salary history pattern.
Yes.
Okay, so your current salary also, you will put all these constraints. Okay, so you will have all this. Then you have naming also with your HR department, all that you will be doing. Okay, so now these are all your useful management queries here. Okay, so now we will go back here. Okay, we have something. This is an exercise. Okay, add row level security or column masking. Okay, so if handling private information, sensitive salary data, so you are handling a sensitive personal identifiable information, so you want to hide or some row level security. Okay, for your company database. Okay, so let's say how you are going to protect that sensitive salary data at both row and column level. Okay, this is one exercise that we have added it here.
Oh, this is row and column level.
Yeah, this is your row and column. So where we will be hiding some information. Okay, you are not giving all the information, you are masking it. Okay, so you have data model here, you have departments, you have employees, and you have
It is
salaries.
it is all in backend, right?
Sorry.
It is all in static, in backend, right?
Yeah, this is all in static. Okay, so let's say you want to you are generating credit card report. Okay, so if you are generating credit card report, you will not see your credit card number in the statement. Have you seen that complete number? So in banking accounts also, you will not see that complete bank account number. They will mask that. Okay, so because of the security reason. Okay, now you have all this one together now.
No, but in both you can see, but online they always when it will not show,
Yeah,
right?
yeah, this is how it will be done. Okay, so you are masking the data here. Okay, so this is how it works. Okay, let me zoom it further. Okay, I will put 350 now. Okay, so you have it, you have users. Okay, employees and others. Okay, these are restricted, these people are restricted, they should not be seeing that access. Okay, so HR can see. Okay, and employees, they can see that their own information, that's it, they should not be seeing other information. Okay, so you are putting a security layers here at the row level security. Okay, so you are filtering rows based on the user identity role. Okay, So this is called defense in depth. Okay. Row level security controls. Who can see the rows? Okay. And you have DDM controls, data management. Who can controls what data they can see. Okay. So what will be the benefits here is, so you are going to protect the personal identifiable information like names and emails. So let's say these are the insurance company guys. If they know my email, so I will get bombardment of the emails from tomorrow. Okay. So I need this one information to be protected. So I need to have a secure sensitive data. Salaries should not be visible to other persons. Okay. You need to ensure least privilege access. So you should not give access to employees to see others' data. Okay. Whatever is least required to do there, that only they have to see. Okay. And they should not be changing any schema here. So this is what you will be having a key benefit of your masking the information. Okay. So now you are masking the data here, data masking. Okay. So you have a mask function email. Okay. Add masked with function is equal to email. Okay. So then once you alter this table, okay, you are altering the column email here. Okay. So then this information, it will be masked. They will not be shown with the complete email address. It will show like this. If you mask it something with this, okay, mask the salary here. Okay. You show the first two and last two digits. Okay. Then the first name and last name. Okay. Show only this XX, that's it. Show first name. This is how the credit cards will be using. So your password will be first 4 letters and then your date of birth, like that. Okay. This is how they will use. Okay. So now you are granting the grant unmask to HR admin role. Okay. So these users can see complete data. So these users will actually see the data here. Okay. So if you want to revoke that, you will revoke it with unmask. Then HR will also not be able to see that. Okay. So these are the functions. This is how it will look like. Okay. So this is your example, and this is your email, and this is the partial salary. Okay. How it will look like. Then your random here. So if you want to give some random numbers, it will give some random here.
Random number.
Random number means any random number from 1000 to 10,000. You want to give some ID. Let's say you are generating some receipt. Okay. So or some ID for that transaction. So you will be giving that random number. Okay. So now you are doing it for filter and block. Okay. This will limit a user can see based on their identity. Now you are applying all the security policies to the tables, to the employee tables, and for the security reason also, for HR security on the employee ID. So this is how you will be doing it. Okay. So then you have, so part 3. Okay. So then you are doing it. Okay. So you are testing it. Setup roles, HR admin, You have user HR Alice and user Bob as a normal employee. So you are giving the permission as unmask and full access. So the regular employee Bob sees like this, first name and last name, and then like this. Okay. Base salary mask, email also mask. Then you are testing the HR role here. Okay. Execute as user Alice dot John. Okay. You are executing it to see the table.
Yeah.
Okay. He is seeing the complete table here. Okay.
Unmask mean it will not exit anything. Right? Mean it will not show.
Yeah, it
You
will
will
not show. It will not show whatever you have masked it. It will not show that. So that you need to define in the masked here. So if you are not using masked means it will show everything. There is no use of unmasking it. You need to define what you are trying to mask. Okay? That will be your business or privacy.
Yes.
Okay? So this is how you are going to apply it for a sensitive information. Okay? So this is all your. Then you are doing it, restricting this, then filter block. Okay. Modification all this. Okay. This is how you have done. Okay. Now you are writing the basic queries here. Okay. So how you are doing this basic queries? Okay. So now the schema is done. So now you are filtering and all you are taking it. Okay. You are writing the basic queries. Let's say the DMLs here. Okay. So you are using the company here, company HR. Select. Okay. First name, last name, email, hire date. Okay. From the employees here. Okay. Where is active is equal to 1 and hire date is this date. Okay. So you are ordering by last name. So this name it should be ordered by this. Okay. First name ascending. So first name it should be ascending. Okay. Last name it should be ascending also. So based on this it will be giving you results here. Then you are joining this with the department now and the salaries, current department plus latest salaries. You are joining these two tables here. Now you see it from DBO tables and you are joining departments and salaries. Okay.
Yes.
You are going to join these three tables here. Okay. From there you are extracting this information. Okay. So then now you are inserting a record in the employees here. Okay. So you are inserting one record. Okay. Then you are updating it with the primary key here. So someone has done it wrongly. Okay. Then you are modifying it. Okay. So where you are using it, employee ID is equal to 2. Okay. Then you are using it as an inactive. Marks employee ID with ID2 as a inactive soft delete. Okay. So you will be making it. Okay. This will be inactive. Okay. So then you are deleting it. So use delete with caution. Okay. So you are deleting from particular employee ID with the effective date. Okay. Now this is where you are viewing this system catalogs. So how you will be using? Then you will be using it. Select database ID, create then from the sys databases. So then you will be pulling that information, okay, whatever you have it in the databases. Okay. So then now you are listing all the tables, list tables in the current database. Okay. So now you are selecting it, your schema name, where is your schema? It is in DBO, and then you have departments, and then you have created date and modified date of that particular department. Okay. So these are all your columns. Okay. You are listing all the columns in a table. Okay. And then you are joining the types here. Dot system types. From all these information you are extracting it. Okay. You are counting this. Normally you are counting the characters or list of the employees.
Counting.
Yeah. So these are all your queries. Okay. So how you are going to do? These are all the queries that I have already added here.
Yes.
So how you are going to do that? Okay. So then you have system catalogs here. Okay.
Okay.
Now you are viewing it with the system catalogs here. How you are going to view? Okay. So let's see that one as well. So now you are querying it with your SQL metadata. Okay. Query the SQL server. Okay. So now you are selecting it, all these details from the system database. Okay. It will list all the users, user databases with the key properties here. So now you are seeing this, all the databases when it got created. You have company HR, your company
Please
HR
maximize
development.
this, maximize little bit. Just, okay. Okay.
Okay. So these are all your databases. How many databases you have created? Okay.
Yeah.
Okay. This is your query schema. Okay. This is your company HR development reporting database. So whether this is online or offline, created date, all that information it will show. Okay. Then it will have a database level tables. Okay. So what type of schema name you have here? Okay. DBO. Then you have columns. What are the columns here you have? Okay. In you are extracting it from the dbo.employees. Okay. Select the all columns whatever you have given. Okay. Is null, no. Okay. You have here is null, nullable, yes. A department ID. Okay. You have all listing all the results here. Column details. Then you have here foreign key. What are the foreign key? So we are extracting it with this name here. These are all your system view, catalog view, okay, which will give the information of the schema. Okay, how your schema is defined. Then you have something called optimization here. Okay. So this we have covered this commands. Okay. These commands we have done. Okay. So then what we will do? We will cover other commands also. Okay. We will see the queries. Let me see which one we will cover the next. Okay. Data types. Table. Okay. Queries we completed. We will go with the class here. Okay. What are the class?
Class.
Yeah. from, join, where, group by, having, all
Yeah.
that. So like
Yeah.
conditions, okay.
Mhm.
So we will do it tomorrow. Also we will do it. So we
Sir,
will.
sir, the I this one. Hello.
Yes, yes.